Welcome to Alpha Mathematical Institute, Avadi, Chennai. In this video, we are going to look a problem on integral equation. Now, let us see the problem. The integral equation y of x is equal to x minus integral 1 to x into y of t into dt, where y belongs to C1 of closed interval 1 comma infinity has a solution. Four options are available. Okay, right. So first we need to solve this integral equation, and then we need to understand what is y belongs to C1 of 1 comma infinity. Okay, so y belongs to C1 of 1 comma infinity means y is a function whose domain is closed interval 1 comma open infinity. Okay, and then whose derivative also exists, that derivative is continuous also. Okay, so this is the meaning of y belongs to C1 class of function, right? Now this is my given integral, y of x is equal to this one. Before solving this integral, we need to know the Leibniz rule for differentiation, integral, the integral sign. Okay, suppose if I am having the function f of x comma t on two variable, I need to differentiate, I need to integrate this function with respect to t within the limit some h of x to g of x, but my aim is to differentiate this integral. So d by dx of this integral is nothing but integral h of x to g of x. First, partial derivative of this function with respect to x. So dou f by dou x into dt. Next, plus derivative of the upper limit g dash of x into f of x comma f of x comma. Instead of this t, we need to substitute the upper limit. Upper limit is g of x. Okay, and then minus derivative of lower limit h dash of x into f of x comma. Instead of this t, we need to substitute the lower limit h of x, lower limit h of x. Okay, so this is called Leibniz rule. We are going to apply this rule on this problem. Okay, right, let us look into the problem. Here the problem is this one, y of x is equal to x minus integral 1 to x minus integral 1 to x into y of t into dt, x into y of t into dt. Okay, so this is given information, right? Now differentiate this function with respect to x. So I will get y dash of x is equal to, if I differentiate x, I will get 1 here. Okay, if I differentiate x, I will get 1 here, minus, here I need to use Leibniz rule, right? So integral 1 to x, I need to differentiate this x partially with respect to x, so it will become 1 into y of t into dt. Next, plus upper limit, derivative of upper limit is 1. I need to replace this t by that x, so x into y of x, and then next I need to differentiate the lower limit. It will become derivative of 1 is nothing but 0, so 0 into something, it's going to be 0, so I am leaving it, right? So here minus is common to all, right? So it will become 1 minus integral 1 to x y of t into dt, y of t into dt, plus x into y of x, x into y of x. Okay, x into y of x. So this is your y dash of x, that is y dash of x is equal to 1 minus integral 1 to x y of t into dt minus x into y of x, minus x into y of x, right? So call this as equation number 1. Okay, and then call this as equation number 2. From first equation, I can write y of x is equal to x into 1 minus integral 1 to x y of t into dt. Okay, y of t into dt. From this integral I can take this x outside, because here the integration with respect to t only, so I can take this x outside, right? So I'll get x outside here, and then here also I am having x, here also I am having x. I am pulling out one x outside, right? So from this I'll get y of x divided by x, y of x divided by x is equal to 1 minus integral 1 to x y of t into dt. Okay, y of t into dt. So call this as equation number 3. Call this as equation number 3. Here I am having that expression 1 minus integral 1 to x y of t into dt. So instead of this quantity, replace y of x divided by x. So put 3 into I'll get y dash of x is equal to y dash of x is equals to y of x divided by x, y of x divided by x. Instead of this, minus x into y of x, minus x into y of x, right? So this can be rewritten as here also y of x, here also y of x. Just to pull out y of x outside, it will become 1 by x minus x. Okay, so from this you bring this y of x into this side. Y dash of x divided by y of x is equal to 1 by x minus x. Okay, and then integrate on both sides. You will get log of y of x is equals to, here integral of 1 by x is log x minus integral of x is x square divided by 2. I need to add up one constant also, plus c. Now bring this log x into this side. So I will get log of y of x minus log x is equal to minus x square divided by 2 plus 1 constant c. It can be written as log of y of x divided by x is equal to minus x square by 2 plus 1 constant c. Okay, so plus 1 constant c, it will come minus x square by 2 plus 1 constant c will come, right? So taking exponential on both sides, I'll get y of x divided by x is equal to e power minus x square by 2 plus c, minus x square by 2 plus c. So this can be rewritten as e power minus x square by 2 into e power c. Okay, so e power c is nothing but a into e power minus x square by 2. So this is some another constant where a equals to e power c. So this is y of x divided by x. So from this I'll get y of x is equal to a times x into e power minus x square divided by 2. Y of x is equal to a times x into e power minus x square by 2, but I need to calculate what is a. Okay, what is a? So now look at equation number 1. This is equation number 1. Here you substitute y equals to 1. So y of 1 is equal to, here I will get 1 minus this is 0. So y of 1 is equal to 1. So this information is going to help to find the value of a. Y of 1 is equals to 1, I know. So from this, here substitute a, x equal to 1. So a into 1 into e power minus 1 divided by 2 is equal to 1. Okay, y of 1 is 1. Here I am substituting x equals to 1. So it will become a into e power minus 1 by 2 equals to 1. So a equals to e power 1 by 2. Now replace a equals to e power 1 by 2 here. Okay, so I know y of x is equals to ax into e power minus x square by 2, minus x square by 2. But I know this a is nothing but e power 1 by 2 into x to e power minus x square by 2. So it will become x into e power 1 by 2 minus x square by 2. So it will become x into e power 1 by 2 into 1 minus x square. So this is the solution to the problem. Y of x is equal to x into e power 1 by 2 into 1 minus x square. Now let us look into the options. Y of x is equal to x into e power 1 minus x square divided by 2. Option 3 is correct. Okay friends, if you like this video, please subscribe our channel and share this video with your friends also. Thank you.